7 basic quality tools. Those are flowchart, histogram, Pareto chart, fishbone diagram, which can also be called as Ishikawa diagram or cause and effect diagram. And what else? Control chart, check sheet, and then scatter diagram. Okay, so when we spoke about flow chart, it is a pictorial representation of the process. So you may depict your process, maybe related to the quality or the entire process also. You may depict it in a pictorial form to give a visual impact to the process. So why this has been included in quality tool? Let me share the image, a simple format. So every steps, it would be depicted in this way, which you're following. So how this is helpful in managing the quality? See, when there is a see through this, you see the different steps and the flow of the processes. So from here, you can identify any non-value add steps and any process improvement areas. Got it? So anything which is not adding value, you can remove those steps, or also identify whether there is any or possibility of automation by which you can bring in efficiency into the project, right? So this is flowchart. And what is the next tool? Histogram. Histogram is nothing but your simple bar chart. In school days, you would have seen the representation of the data as a bar chart is what is histogram, right? So this is your histogram, and this is your bar chart, which is your histogram. So how this is useful? See, when you're going to have your data as a table, it may not be too appealing, or you may not be able to identify the trend. But on the other hand, if you're going to depict it as a image, now if you see, you can see 41 to 50 frequency is the highest contributor, and likewise the least is 0 to 10. So if it is mentioned in an Excel sheet as a table, you may not immediately capture that, but representing it in a pictorial way, it helps you to capture the situation or the scenario much quicker. And then Pareto chart. So when we are talking about Pareto chart, it is 80-20 rule. Okay, let me explain. See, 80-20 rule, which means the vital few contributes to the trivial many. That is, 20% contributes to the 80%. See, in your project, in your organization, maybe there are lots of defects. If you analyze these defects, you can understand that 20% of the defect heads are contributing to the 80% of the issues. And this applies anywhere and everywhere. If you see the productivity, your 20% of your team would be contributing to the 80% of the productivity. You can analyze and you can see that it holds good everywhere. And even for your personal life, 80% of your time goes in, 20% of the activities, and so on. To make it simple, I can give another example. 80% of the world wealth has been handled by only 20% of the population. I hope at least this example will give you a better clarity of 80-20 rule. So how this is being used in quality management? Let me share data. See, if you're going to identify which 20% is contributing to the 80%, then you can focus on those 20% alone. If you see here, the data has been presented in ascending order, and through weighted average method, you can see that 80% is plotted here. And if you cut it down, you can see that these three are contributing to the 80% of the issues, right? So out of the 7 issues, these 3. If you sum up, there are 1,500 issues. If you're going to address these 3, you would be addressing 1,500 issues. You'll be resolving 1,500 issues. If you do not do that and randomly put your efforts, let's say you are addressing this, this, and this, you would have hardly covered some 200 or 300 and odd issues only would have been resolved. So what is the benefit of Pareto chart? It helps us to identify which is the major contributor, and from there you know that where you need to focus. And then let us see what is fishbone diagram. So fishbone diagram is a root cause analysis tool. As it is in the form of fishbone, we call that as fishbone diagram. So let me show the image. See, let's take an issue which you want to address is major defects. There are more defects, you want to arrest those defects. Now, instead of like you're going to bring in your people and you're going to discuss what can be the contributors for the defects. So instead of randomly thinking, you can have some subtopics or topics based on which you can identify the defects. Say for example, the categories have been represented as the subbone here. Here they have category referring to the categories as material, machine, personal, and process. Okay, so basically there may be like 4M, and there is also something called as 7M. It seems we are not going into those details. So here the category, instead of randomly identifying or discussing the ideas or the contributors, we can have categories like, in this case they are having like material, machine, personal, and process. When it comes to material, here they have like when you discuss, you may ask questions. What is that defects which is contributing from the material? Maybe a damaged material is used, that is what is contributing to the defect. Somebody may say incorrect material is used, that is why the major defect. Or there may be somebody who say that there is an incorrect combination of the defects, right? And now you may ask, okay, based on machine, what can be the various reasons contributing to the defect? Then somebody may say, maybe there is a bad tuning. Now, when we are speaking about machine, we are going to discuss which is going to contribute to the based on the machine. Maybe bad tuning, a defective machine was used. And when it comes to people, that is personal, what can be the reasons contributing to the issue? Maybe people with bad attitude or poor skills, or people with incorrect mapping of the job, right? There can be any reasons. Process, here it is poor planning and wrong technique. So based on these categories, you may ask questions and people may identify or come out with reasons, possible reasons based on these categories. This is fishbone diagram. See, it's look like a fishbone, that is why the name. It has been created by Ishikawa, so we can call it as Ishikawa diagram. And also, as it is a root cause analysis tool, basically the purpose of the tool is to find out the root cause. We call this as cause and effect diagram. And now what other tools are there yet to be covered? Control chart. See, control chart is we are going to check whether the project is within the control or not. When I say whether the project is within control, we will have certain limits or metrics which we have signed up with the client. Okay, so let's say for accuracy, your client would have said like minimum it should be 90%. So less than 90 is not acceptable. That is, for every 100 transactions, 90 transactions has to be right. So they would have asked that as a upper limit, as a lower limit, and the upper limit they may ask for 100. You negotiate and you then say that okay, we can fix it as 95%. So you're signing up with the metrics. There may be various metrics. Just to discuss as an example, you can say quality, accuracy. So the upper limit is 95% and the lower limit is 90%. Okay, so you may have this limit as with the client, sign up with the client. Now You will have your own limit within the team. So what is the limit you may have it within the team? Will it be lesser than this or more than this, or will it be the same? To answer this question, see, with the client you have accepted as 90 to 95. But within your team, you may have something stricter than this, higher than this, because even if the team is going to miss the internally developed metrics, still you will be within the limit which has been signed up with the client. For example, instead of minimum 90, you may sign up as 93 within the team, and the maximum is 98. So even if the 93 somehow it has been missed, you still will be within the limit which has been agreed with the client, right? So there is always, like, mostly there is a internally accepted metrics and a externally accepted metrics. So now this is going to be depicted in a pictorial form, and whatever data you get is also going to be plotted there. So let us see how is it. This is your control chart. If you see here, the orange line is your, so the orange line is your internal limit. See, there is no guideline or a strict rule that your internal limit has to be much more stricter than your external limit, that is your signed up with the client, but logically it makes sense. So control limit and yeah, so the internal limit is called as, that is within your organization, the limits you fix is called as control limit. So this one, the upper blue line, the orange line which has been presented here is called as upper control limit, which we can call it as UCL. So to give an example, internally we can say that as 98%. And this orange line below here can be called as your LSL, lower control limit, which is your 93%. And with the client, you would have agreed, right? 90 to 98. So that is a specification limit. So this dotted blue line is your upper specification limit. So which we call it as USL. And this is your lower specification limit, which is called as LSL. Okay. So this by number, this can be what? Upper, right? 95%. And this is your 90%. And this midline, the thick midline, is your mean, which is your average of your limits. So you plot this, right? Now, every day you do the transactions and you keep plotting it in your in the graph here. Okay. So every day you are testing your accuracy. One day it will be 91, another day it will be 97, 95, 92, and so on. You keep plotting it. So by plotting, what is that you see from the image? From the visual image which you see, you know, like whether it is exceeding the limit or not. See, you see all these things are within the limit, but this particular data point or a particular day, it is touching the control limit, right? So in that case, we can say this is out of control. So you have to be within the limit. If it is crossing, it is out of the control. So you know, like this particular day, the performance was bad. Then you're going to take action to identify why this is bad. Yeah, we identify why it is bad, the performance is bad, and accordingly you're going to take action. So this is your one point to identify whether the project is within control. Another reference point is rule of 7. If you notice here, there are 7 consecutive data points in the same region. That is either above the mean or below the mean consistently. Okay. So this is called as rule of 7, which means 7 data points lying in the same area. So this shows that there is a trend, and eventually this trend will lead you to leave the control limit, right? So what is rule of 7? It shows that 7 consecutive data points falling under the same region is called as rule of 7. So this says that by experience, the experts have said that this will lead you to eventually will lead to go out of the control. So either it is above the mean or below the mean. If there is rule of 7, which gives a warning sign for you to check your action plan and then fix the gap. Got it? So this is your control chart. Next is check sheet. Check sheet is generally people confuse that with checklist. Checklist is a reminder list which helps you to ensure that every steps is being followed religiously. That is checklist. This is check sheet. Check sheet is a defect data gathering technique. Okay, check sheet. So let me share how is it. See, let's say like every day you are checking the quality and you identify some defects. So instead of capturing the defects as like 1 and then remove it as 2 and then mention it as 3, this makes the life tedious. So what are you going to do? When you identify a defect, it has been captured like 1, then second defect, third, fourth, and then fifth can be a cross, which is called as a bundle, where I need not count. When I see this bundle, I know it is 5. For example, on Wednesday, how many wrong orders were there? 5, 10, 15, 20, 22 wrong orders. So this is defect capturing tool is called as check sheet. And then what is the other technique? Scatter diagram. Scatter diagram is to understand the correlation between two data points. Okay, before I share the image, let me ask, cover a scenario. See, you're managing a team and there are lots of defects. You assume that less experienced people are making more defects. That's an assumption, but you have to substantiate that with data. Okay. So what are you going to do? You're going to collect the data and then put it in a graphical way, and you will be able to understand whether the less experienced people are making more defects or is it something else. So let me share the scatter diagram. So if you're going to plot it, for example, here you are plotting as an x-axis the experience, like 0 to 2, 2 to 5 years, 5 to 8, and then 8 plus years. And then in here in y-axis, the count of the defects will be 25, 20, 15, 10, right? And now you're going to plot the defects of each and every one. And if the trend is going to be like this, which shows more the defects, more the experience, more the defects. So more experienced people are making more defects. Or if your data is going to reflect like this, which means less experienced people are making more defects. Got it? So in these cases, you identify that there is a trend. If the first one is going to be your reality, then you know more experienced people are making more defects. Then you may come out with some action plan like job rotation, change of their roles. So these things are going to motivate them to do their work in a better way. So if this trend is going to be where it shows less experienced people are making more defects, maybe you come out with actions like additional training, hands-on, a better KT, and knowledge documentation. So these things can help you to address this issue. Or if the data is going to reflect in this way in this graph, where more experienced people are also making mistakes, less experienced people are also making mistakes, and vice versa. So there is no trend as such. So now you need to find out, is there any other reason which is contributing to the defect? So basically scatter diagram helps you to find out the correlation between the data points. Okay. Yeah. So now if you see here, 7 basic quality tools. So what are those? Flow chart, histogram, Pareto chart, fishbone diagram, control chart, check sheet, and scatter diagram. So here, flow chart is a pictorial representation of the process. What is the purpose of the tool? To identify any non-value add steps and any process improvement, automations, and all those things can be identified. And then histogram, it's a data representation technique like your bar chart, simple as such. And then Pareto chart follows 80-20 rule, where instead of randomly putting your efforts, if you identify which is the major contributor, then you can focus on those areas. That is Pareto chart. Fishbone diagram, also called as Ishikawa diagram or cause and effect diagram, helps you to identify the root cause. Okay. And then control chart helps you to understand whether the process is within control. Check sheet is a defect gathering tool. And then scatter diagram is a tool which helps us to find out the correlation between data points. So I hope you understood what are the 7 basic quality tools and the use of it.